What's that thing they say about bingo cards? Well, this wasn't on mine. This is an emergency repair. This is the Yamaha EMX640 combo PA amp from my studio that has given us good service for, God, about 8 years, I think. And I didn't buy it new, I bought it second hand. And last night, the band that were using it sent me a message to say there was a burning smell and then the PA cut out and it got very hot at the back. So something's gone astray. I've luckily found a service manual for this on Electro Tanya, which is the best website in the world. It's definitely a resource that should be protected at all costs. I did find a service manual for this, and I was surprised to see a printing date at the bottom of 1996. Apparently, yeah, I think these were designed in the 90s, and I found reference to someone saying online that they bought one in 1999. I had no idea it was potentially that old. I have been in this before. A really common issue with these is the XLR sockets on the front. The solder joints can crack on them, so they start being intermittent with mics. Thankfully, if you take the front panel off, the entire mixer section is contained in the front panel on like one panel, and there's a couple of like ribbon connectors that just unplug and the whole thing comes off dead easily. The solder joints are right there, so it's dead easy to do that quick service if you've ever got issues with these, with the joints on the sockets. Probably just as easy as well just to get into things like, you know, if you've got to service any of the pots or anything. It's not too bad in that respect. Obviously all the power amp section and power supply is on this massive heatsink on the back, which I'm going to get in from the front first. As I say, I've been in this before, so I know sort of what's going on there. It's got quite nice Sanken output transistors, I believe. They're quite well made. I find this with most Yamaha stuff, it's just such a battle axe. It's just so dependable. But like most things, you know, they'll give you a service for so many years and then they might fall over at some point. As I say, I bought it second hand, so I don't know for definite its age. I've got the matching speakers and everything with this as well. It's not a speaker issue because I've checked impedance of speakers, nothing shorted or blown. It didn't go with a bang, I'm told. There was just a burning smell and it got hotter and hotter. And then it just cut out, the power's gone completely. So I'm going to pull the front panel off. I could smell it when even when it was off. So I'm going to pull that front panel off and see if we can find where the damage might have sprayed itself all over the insides of it, and see what we're going to do about it, because otherwise the studio's not got a PA system. So we've got a couple of retainers and a connector comes out in the back. That's it. Easy peasy. I'm hoping we don't have a transformer issue, because if I have to replace that, I think it's going to be more than the value of an entire unit. So we'll have to check. We have a fuse that's smoked. That is a time lag 3.15 amp. I'll have to find out what that is on, because I believe there's a couple more fuses. Yeah, down at the bottom there's a couple of fuses here which I believe are on the, I think are on the plus and minus 15 volt rails. I'll have to look at the service manual. I think what I'm able to do here is disconnect these cables. So we've got one I've disconnected there that comes from the transformer, and then this one that goes out to the speaker jacks. If I can get to the top clip to release it. There we go. And then I believe this whole board on the heatsink, if I remove these 4 screws on the outside, so we're just out of shot, I believe this whole heatsink can come out of the cabinet with the whole board attached. Let's try that. So we have it on the bench. We have one blown primary fuse, and I've just been going around and just doing a few tests on this. Now it's kind of a weird setup. It's not a stereo mixer, but it is a 2-channel power amplifier, so they sort of design it to be used with a main output and a monitor output. So the mixer being mono means you've got no pan controls or anything. You can't individually send things to one or the other apart from using the main and monitor. It does have sort of stereo channels on the front, but they just sum to mono. It doesn't actually do anything. So a couple of things I've noticed from looking around this. The inductor here looks like it's overheated, so something's up there, and I think it's this side that's the power amp side, because I was sort of checking around for shorts and I've realized that across for some reason that one only fails one way, which is a 2SB1647, but these all fail both ways. They're all shorted, and every diode I've checked on this side is shorted. Now on the other side, interesting, that one's not showing shorted. Oh, it is that way, but not that way. Maybe it's just low resistance. That's again 2SB1647. Yeah, that's showing short both ways. And every diode I've checked across is also showing that same short. On the other side, well, that one didn't. We've got some different bit of the circuit. Oh no, it is. So on the other side, that doesn't happen. The other side, you just get the one blip. With a sort of diode check, but the meter doesn't show shorts. So I think that side's a monitor side, which never gets used, and this side's a power amp side. And it looks like I'm going to have all these screws out, and then there are 4 screws in the board. Can't see any more, and then that should let me remove the board. There are no shorts I can find across the bridge rectifier. That seems okay, and the 2 fuses at the bottom, they're fine because they power the plus and minus 15 volt rails, the regulators for which are there, and again they're not showing a short. They're showing okay, apart from that one. What's going on there? Oh no, I must have been touching the probes. That's fine. I'm not reading a short there. It's actually marked on the power connector there that we've got 2 ground points, plus and minus 21 AC and a plus and minus 65 AC. Again, I don't measure anything on the power side apart from the capacitor beep there, but yeah, no shorts there. I've been doing a bit of investigating, and there's a tiny switching transistor here. This is Q121, and its partner on the other side, Q221, is down here. So those 2. If I measure emitter to base on either of those, I get about 2 ohms across them, so it's the 2.1, and if I measure the same on the other side, I get the same thing. But if I measure emitter to collector, if I get this right, that is the emitter side, yes. If I measure emitter to collector on the good side, I get several megohms. If I measure emitter to collector on the bad side of this little switching transistor, I get 47 ohms. I think the reason is there's a 47 ohm resistor, looking at the diagram, that is just across Q123, which is this one. So we've got a 47 ohm resistor. That resistor is R135. If I can spot that there, our 135 is there. I think we're measuring that resistance because we've got a loop coming from the short. That makes me wonder if Q119, because this one might be where our short lives, because that would also mean that if there is a loop there, L101, which is this inductor that looks melted, would have been right in the firing line. It says it's rated at 3 amps, 68 microhenries at 3 amps. So possibly that one. Now I don't want to completely desolder it because the height of it is critical. It's going to be difficult if I have to try and replace that, because obviously once it's on the heat sink I can't reflow the joints. So I think what I'm going to try and do is desolder one pin and see if that will, if you can see if I can insulate it, and see if that will be enough to potentially clear the short. If the short exists still on the board, I'll know it's elsewhere, but we'll give it a try. I think we've got them. So I've desoldered the centre pins on these two. We've got Q118 and Q123. The one for Q118, if I now touch to the pad and the pin there, I've got a 4K resistance. If I touch it to the pin itself, which is desoldered from the pad, I've got a short. So that's got a short. This one down here was unrelated to the circuit up here, but was also shorted. Again, if I touch to the pad, it's on my meter there, I'm getting nearly 3 megs resistance. If I touch it to the pin, again I've got a dead short. So these two have got to come out. So we've got one of each, PNP and NPN. So I'm going to take both of those out completely. So again, now they've been removed. I'm also getting short on this bottom one. And again, not on the other side. Again, let's do the central pin. It to the pad, 15 meg ohms to the pin, shorted. Alright, after a little break, I've got new transistors. So I've got the D2560s, which are ISC brand, the ones I've gone for. And I've got the 2SB1647. It's marked on the board, thankfully, that the D's go there and the B goes there. And I've also got 2 new inductors, which are considerably smaller than the originals, despite apparently being the same rating. The originals, if I can find the scrap ones, were made by Teo Uden. Unfortunately discontinued, so I can't find equivalents. Now these do have a sort of plastic casing around them, and the actual coil inside is quite a bit smaller than the outside of this casing. Because one of them is measuring as a resistor, not as an inductor, it makes me think that there's possibly a short in one of them. It may have melted the coating on the magnet wire when it overheated. I struggled to get one with the right pin spacing. These are something like, I think it was 8mm spacing or something, 7.5 or 8.5mm spacing. I could only generally find 5 or 10mm spacing, and something with the longer pins like this I think I'm more likely to get to fit than something with the shorter pins like this, where they're a bit thicker, and of course they're fixed to the base of the bobbin that the coil is wound around. So you can't really flex these, whereas these I might be able to get a little bit of leeway to bend them because they're a bit longer. If I can test which one of these was the one that was actually damaged, I could be tempted to cut the plastic casing apart and just see how much difference there is in the coil size. But as I say, these are the same inductance and claim to be rated to 3 amps. I can't remember the exact part number that I got. I'll put it in a box down below if I can find it again. So the tricky bit with this, as I think I alluded to earlier, is getting the transistors to lay flat at the correct level, because I can't screw this to the heatsink and solder them in place, because obviously the heatsink covers up the bottom of the board, which is a shame, because that's generally a way I prefer to do it if possible, to actually fix it to the heatsink first and then solder it, so there's no risk of screwing down a chip and then it pulling on these solder joints. You can't at least reflow, so I have to try and do my best with that, really. Obviously I'm going to have to bend and probably trim the legs first and see if we can get this to work. So I've got a long set here and it seems to be bent fairly closely to the wider part of the leg there, so about there, if I can about match it. Been having to think about this and I've come up with a bit of a solution. The holes for the larger packages here, for the driver packages, are evenly spaced. It's only the hole for the bridge rectifier, which would be on this side, and the holes for the two 15 volt plus and minus rectifiers here, which are a closer spacing. But what I've managed to do is flip the heatsink and the board upside down and effectively screw the chips upside down, not tightly but just enough to hold them in place. Just prop the board up, because it's partly propped up by the large capacitors on the other side of this. Prop this edge up of the board with this little pot I've got full of shrapnel and bits and bobs, which is conveniently the perfect height. And I haven't soldered these yet, I've just put them through, and it's allowed me to secure them in place and then check that the backs of them are all level and that the board is parallel enough with the heatsink that I can now clip these legs and then solder them. I think I'm going to clip them first and then solder them. Just make sure they are right in the center of the hole, they're not pressing against the edge of the board, so that they'll be secured and they'll be flat, and it should take out the guesswork of getting these level, so that when it's flipped onto the correct side of the heatsink and these are face down against the strip, against the sill pad there, once they're against that, they should lay nice and flat. Might sound like I'm dwelling on the point a little bit, but I was concerned about just vaguely jamming them in and then hoping they would just press against the heatsink and not stress the solder connections, which I absolutely believe they would if I just guessed it. I did, by the way, check every diode around the circuit, and the smaller transistors I did run a diode check. I found no other shorts. I still have guarantees that this is going to be the absolute fix, or that it won't go up again. I hope not. But as this is 25 quid's worth of parts, it made sense to me to do some due diligence before just throwing these in and praying. I still believe that it was just general fatigue that caused the issue. I'm not sure I believe that there was certainly no misuse or mishandling of the PA, and I don't think it had developed any great fault particularly. I think it had just overheated and caused one of these devices to short, which I think was a cascade failure. I'm just going to solder the middle pins first. When it's being handled, they do get knocked about a little bit, but again, once they're bolted back down, it shouldn't be a problem. I think before I fully assemble it, I will clean the backs of all these heat sinks with isopropanol. We don't need any heatsink compound on this, because again it uses sill pads. You shouldn't mix the two. I'm glad it uses sill pads actually, because it makes the service much, in fact that's got a sill pad still attached to it, it makes the servicing much easier. And you must remember to put them on before you reassemble it, put the board back in, because these heat sinks will likely be connected to the collectors, I would imagine, and this heat sink is of course grounded, so you short it straight to ground if you bolt it on without the sill pad, because all of these, if I take one out actually, all of these transistors actually have a little plastic shroud, and the screw hole is plastic. It's part of the plastic casing. The screw hole isn't exposed metal. So you can see there it's got a little black plastic shroud around the screw hole itself, and it's only the outer that the actual heat sink is connected to. So if this is done properly and they're kept neatly in line, there shouldn't be any risk of that shorting against the ground. In my never-ending determination to make everything take far too long, I had a bit of a break on this and come back to it. So much for it being an emergency repair. If I haven't mentioned already, I was very kindly lent a PA system in the meantime to continue the rehearsals and everything at the studio. But just to catch up, the board is obviously bolted back on. That wasn't quite without tribulation, because even with all my attempts to try and get these all straight and even and be very careful about how I screwed it in, there was still one, I think it was this one, that was troublesome, and I ended up having to get my tap and die set out and just kind of not completely recut, but just tidy up a little bit the thread on the heatsink, because one of the screws was just determined to bind up all wrong and cross thread. So I managed to sort that out, and then I just strategically went around it and just tried to kind of keep an even tension and not over tighten, but just snug down every screw, the 4 on the board, and every one of course on every chip. Just make sure everything was laying flat and there were no creases or crinkles or bits sliding away on the sill pads. One thing I have checked, but I'll do it here just to prove the point. Before you power these on, when they've got sill pads and such like this into a grounded metal heat sink, check the resistance between every screw and if that's not resistance, that would help us. Check the resistance between every screw and every top tab, because the top tab will be the collector. Of course, the screw is the directly connected to the heat sink, and the heat sink will be grounded. You don't want any of these to be grounded because you'll short the collector to ground. So I went through and checked every single one, and there's one somewhere that measures something like 30 meg ohms or something before it goes off the scale. So we've got no issue there. Obviously those are plastic, so those don't matter, they don't have an exposed collector. But anything that does, we'll just go around and make sure that there are no shorts, no slips in the sill pad. That one's fine. And of course again, the rectifier's got a plastic case. The only slight concern I've got is these inductors. Now this was a bit of a strange one, because I've taken apart, if I don't drop it, one of the original inductors, just cut the outer resin case off it, and I can definitely, well, when I did it, I could definitely smell that it got that burny electronic smell, so it's obviously been well cooked. There's some glue around the middle of that. I'm not sure if they use that to hold the resin on, or if that is damage from being overheated. But the service manual says these should be rated at 3 amps maximum current. That is a Teo Uden part, which is unfortunately discontinued, else I would have replaced them with exactly the same thing. But when I look at the spec sheet for this, it says the maximum current rating, the original part, is 2.4 amps. These replacement ones, which are much smaller, claim to have a maximum current rating of I think it was 3 amps, but have something like a 2 amp saturation current. I am concerned that they're way smaller. I can't find anything, as I may have mentioned earlier, in this 7.5mm pitch. They're either 5 or 10mm, and the 10mm ones tend to have quite stout legs like these that I don't think I'm going to be able to bend without breaking them, whereas the legs on these are a little bit more, they're a bit longer and just a bit more malleable. So I was able to get these two new inductors in there. I'm just going to hope they're going to be alright. As I say, they apparently are rated at 3 amps. And I've put some silicone glue around the big capacitors here, because what was there is actually cracked. That again wasn't without tribulation, because the end of my silicone glue had set, even though it had the cap on and it was in a sealed bag. When I tried to squeeze it, it actually burst the other end of the tube, so I had to get it out of there. And it wasn't cheap stuff either, it's the Chip Quick stuff, which I'm a bit disappointed in for setting. But anyway, so again, I've done diode test on everything. I've done the ground check against the heat sink. I've changed the fuse in the power supply in the cab. So I think we're just going to have to brave it, just turn it on and see. Now I've got to fathom out, I need a way of loading the jack outputs to my dummy load, because I'd like to put an input to it, and I'd like to put it on the scope and see what our output is doing, check we've got any odd clipping or anything if we get that far. So I'm going to bolt this back into the cab, and we know those fuses are fine. Yeah, I'm going to bolt this back in the cab and can reconnect it all, see what it does. Okay, amps back in the cab. I've temporarily just screwed the mixer to the front. There's a couple of screws. I've got a dummy load wired across the main output, and I've got the meter measuring for any DC across it. Let's put power on, see what it does. So we've got a limiter light stuck on, but no DC. So there's two possible scenarios here. One is that the clip and limiter circuit is faulty. Another scenario is that the clip and limiter circuit and the indicator are fine, and they're actually indicating a fault elsewhere in the circuit, so it's doing its job. So I had to pull all this all back out and try and take some measurements and go around it, and I had to end up printing the schematic out and laying it across 4 pieces of paper, because having it in the PDF across 4 pages and scrolling up and down was just impossible to follow. It made much more sense when I could follow it kind of all together. So quite conveniently, it's marked on this board which section does what. And we've got the limiter section here, and then just below that the clip indicator section. And from the schematic I've been able to tell which channels come in, or where the channels come in to the limiter circuit. And we've got R150 down here and R250 at the other side is where that comes in. And I'm measuring odd voltages on them. Now if I just pop the power on, they're on volts, yeah. If I check R250, which was the original good side, on there I've got 26 volts on one side of that resistor and 13.5 volts on the other side of that resistor. Now if I check R150, I've got a negative voltage, negative 76 volts, and 23 volts on the other side of that resistor. But yeah, negative voltage. What on earth is going on there? Which again, just a sanity check. 26 volts positive, 13 volts positive. Something very odd going on there. I went round and tried to find any potential shorts or issues or opens. Couldn't find anything until I went back to this 2SB1647 that I replaced. I've always been on the back foot a little bit about this because it doesn't quite look right. The legs look very thin on it. I was a bit concerned it was a fake. I was doing the tests around everything, diode checks and everything, just couldn't find anything that was out of the ordinary until I came to that, and that was the first smoking gun potentially. I'm hoping this is not a red herring, but of course there are 6 of each power transistor on the board, so you've got 5 others to choose from to take measurements. And if I check any other 2SB1647, I can get a about a 0.4 to 0.6 volt diode drop with the positive on the collector, and again they all test the same, but this one will work that way. Now gives me a really different reading on the other way. So from base to collector, it gives me either a huge drop or it just goes open. That's probably because there's some voltage discharging or capacitor discharging, but the readings are really different. And if I go the opposite way, again I can get a drop there between, that'll be base and emitter, won't it, the opposite way, and that would be open. But on this one I get a reading. See, nothing on that one. That one does show short because it actually shows short on both sides, or almost a short, so that's correct. That's in the switching circuit. It just exhibits a really different result to the others. There's a very definite 0.6 drop there, that way around. It's the opposite. What's going on there? Is it a NPN chip when it should be a PNP? Is it a fake? I think I need to take that out of the board, and I'm just going to unbolt it all again, take that out and see what's going on there, measure that out of circuit. Coincidentally, I just mentioned, if I do the same test on the blown one, because there's a collector to emitter short on the blown one, but the base to collector still works, still shows the correct drop. If I try that on this one, it doesn't work. But if I go the other way around, it works. What's happening there? The one that we took out originally and the one that I've just taken out, the replacement, base, collector, emitter, they're PNP, so we should have a positive collector. Now we know we've got a working base to collector junction. On this one the emitter collector are shorted, but on the other one we should also have a functioning base to collector junction, and that way around it does nothing. But if I swap it, it shows a 0.6 drop in the wrong direction, and yep, should be that way. Collector to emitter shows open in that direction, or at least doesn't read anything. Nothing in that direction. So what on earth is going on there? Admittedly, I don't think I checked that before I put it in. I wish I had. But I don't really believe there's a fault on the amplifier, because I've tested everything around that circuit. Let me tip you around. There. I've tested everything around there. I've tested all these diodes. I've checked the two driver transistors, checked this one down here, checked everything else. They all measure as they should. So what's going on with this mystery replacement? It just never really looked quite right from the start. I should have checked that. I'm going to order another one from a different supplier at more money, and I might even get two, and see if that makes any difference. New transistors are in. They actually arrived way quicker than I expected. The supplier that I got these from is one of those suppliers that tracks down of obsolete components and such, and as such they have to get them usually from other places, and they can take a long time in doing that. That's fair enough. They must have had these in stock because they arrived within a couple of days. Even in the packet, obviously this is a proper anti-static bag. This one that's very questionable turned up in something that you'd probably get like AliExpress earrings in or something, so that's already a good sign. The packages look completely different. Let's take one out and measure it. Yeah, massively different. And if I can find the original, so this is the one that originally came out of the amp. Again, the tabs look the same. The thickness of the pins looks about the same. The bodies look more or less the same. They've got digits in the in little holes in the front there. That one does as well actually, but the holes on the back look the same. They don't. That one's much thicker. So yeah, I think we're on a better footing for a start. So do a diode test. Yep, get the correct drop. Okay, everything's screwed back down. Again, I'm just going to check, and I have done the continuity check between all the tabs, the collector tabs and the ground, or rather insulation check I should say. So we're back on diode mode. Let's just again check that we get the same drop against the other one on the other side. Yep, more or less, and the other way. Yep, more or less, and in reverse. Yep, all pretty much the same. Okay, we're reconnected. I'm going to measure the voltage at R150 again to see what we get. The power's on the amp, so I'm going to put the plug on. No limiter light. A click of the relay, which I didn't get before, and I've got 13 volts. That looks a little healthier than it was before. And just on the other side of that resistor, 26 volts. Again, much more in line with what we were getting before. And yeah, I'm satisfied now. I'm getting the click of that. And yeah, I'm satisfied that we're getting the click of that relay there, which we weren't before. That this is probably okay. So I'm going to put some signal into this, put this into a dummy load, and have a look at the outputs from each side and just check that they match. Right, I've hooked the dummy load back up how I wanted to hook it up before that fake transistor was discovered. I have a 500 Hz tone at 1 volt RMS going into the line channel. I've set the master output just at halfway. Everything's down at the moment. I have no power. Let's pop on our power. So this is across our power amp channel that we've repaired. So this is DC coupled, so we don't see any DC offset, which is good. The tiniest little amount. If I raise the channel volume, we're working. There is a slight click and a slight offset there. When I do that, go into the 5 volts per division, that's because of my scope. It has a slight fault on it. It's not because of the amplifier, but that is working. I probably can't take this up to full pelt. This is going into a 4 ohm load, by the way. I probably can't take this right up to full pelt because the cabling I've got won't be thick enough to run that much power. But that's running at 0 on the meter, the output meter there. And what are we getting there? About 18 volts, 20 volts or so. around 0 to +3. On the meter that's at +6, so it's not even showing signs of clipping, which is excellent. Let's just switch that around to compare the monitor channel. Yeah, I can already feel the heat in those wires just from that little test. Yeah, and the heat in the resistors there, so it's definitely working. Okay, switching to power amp side 2. This was the side that was originally working fine, so this time we're going to bring up the monitor master and raise the monitor channel, and yeah, that's working fine as well. Again, about the same voltage, around about 0 to +3. No signs of clipping there at all. The dummy load, by the way, if I hadn't showed this earlier, is 400 watt 8 ohm resistors that I can wire in parallel if I want. So I did a 4 ohm there to get a 200 watt load. They still get toasty. They are just bolted down to an aluminium project box, a disused project box, a project that got scrapped years ago, only because it was the biggest disposable metal item I had lying around at the time. Obviously the little croc clips and such that I've got, they're not going to take mega amounts of current, so I can't really get this up to 200 watts, but just for a test into a dummy load, for me it works okay. This could be obviously built much better, something with a proper heatsink, maybe even a fan. I could maybe make a bigger one in time if I wanted to, with thicker cable, maybe sockets instead of doing the croc clips. But for the moment, this just proves that we've got no DC offsets on the lobes, no ugly waveforms, not any issues that arise rather than just shoving a speaker into it and blasting a test tone across the hall, which I don't want to do. So it's certainly better than nothing, and it didn't cost me much to make it at all. It gets me through. So 3 original transistors and 2 inductors were damaged, and the fake transistor obviously held up proceedings quite a bit. I laid the blame solely at my own feet, to be honest, for that, because it was a cheap one off eBay. The seller's doing also pairs of these with the 2SB 1647s as well. Sorry, the 2SD 2560s, complementary pairs. I think they're probably just reselling stuff that they probably sourced cheap from abroad. Yeah, it does make me wonder, but I don't think really going to do anything about it now. But obviously sourcing a genuine one has made it work again. I've had that happen before. I'm really glad that it didn't cause apparently any further cascade of failures, because I've had that happen before. It didn't seem to grumble too much about having minus 75 volts in the wrong place, which is probably a testament to these things. I'm really glad to be able to get this back into the practice room. You might think, well, it's only a really basic sort of combo amp. You can do much better with these modern things and separate amps and all this nowadays. To be honest, for the size of my practice room and for letting people use it by themselves, I think this is brilliant, because you almost can't go wrong. It's not too complicated. There aren't features on it or excess power that it just isn't needed for the job. It's fairly idiot proof, and I just think these Yamahas are really solidly built, and this is the first time it's ever let me down. And I wouldn't even say let me down, because it doesn't really owe me anything. I've had it for about 8 years. I've got it second hand, and it's been really solid, really dependable in that time. I'm going to reconfigure how I use it. I'm actually going to use it by splitting the monitor and main. I'm going to turn them into left and right, so we're going to use 2 volume controls for each channel, because it's only drawback with these. You've got 2 amplifiers, but the mix is only mono. So in ordinary use, you actually daisy chain the mains into 2 sort of mono speakers, which again is all right for vocals. But I've had a couple of people ask me, can we run things like stereo electric drums into it, or stereo backing tracks? So I'm going to reconfigure this with main monitor switch down. I'm going to relabel these left and right, which is why I tested both sides. I'm going to run it that way. I think it will be more efficient. I think it will even out the wear on it. But it is a testament to these that apparently they made them since 1996. And if I'm right about this being made around about 2014, where they were still making them 8 years later. So, in fact, no, 18 years later. So, yeah, and the modern ones now have more advanced amplifier circuits and whatnot, and some have got compressors on. I really like those Yamaha compression circuits, by the way. I've used their compact mixers with that circuit on and always got really good results. So if I were to upgrade it, I'd probably try and find one of the modern S models with the compressors on, but I've not got that kind of money right now. I've got other things to pay for. What was the possible cause? Possibly this. This is one of the plugs out the back of one of the speakers, and I noticed when I took it apart that the little tag from the positive contact was like hanging by a whisker, and it may have been touching and shorting out. It could have been also the fact that it just gets used so much. The studio's been very busy, so this can be on for 7-8 hours a day, used by 3 or 4 bands. So again, a testament to it being very dependable, very usable. So I'm looking forward to being able to put this back in. Even a couple of bands have said to me the temporary system we've got in there with a mixer and a separate amp is not as loud as this on the same speakers. So and we certainly didn't see any clipping on the scope as far as I was comfortable to push it with my dummy load. I don't really like these cheap plugs at all. The other, when I say I bought this second hand, the 2 speaker cables that I've got were different. They didn't match. One has got Nutric plugs on, and I think it got genuine speaker cable, which I actually used so long I chopped it in half, and I've wired it up to the current system, which is binding posts on the back. So I'm going to have to get a couple more Nutric plugs to put on the back of the cables I've got to rewire this in with less cable. But yeah, it was sort of 3-core mains flex where the earth core was sort of loosely chopped off, and yeah, just not, feels like hard plastic, just not very good. So I'm going to dump that. I'm going to dump these, get a couple of Nutric plugs. Not a sponsor, by the way, but just there's a reason why people use Nutric plugs for stuff. When you're using them in a professional capacity, yes, they make the difference. So yeah, it's up and running. I'm going to get this back into the studio when it's not chucking it down with rain, and hopefully continue to use it maybe for another 8 years. We'll see. I hope that's of any help or interest to anyone who might have one of these, or might find one that's blown up. Be aware that, yeah, it is a slightly unusual topology. It has a sort of switching element to it and a cascade element to it that I don't fully understand, but these are in just the linear amp section. But if you can find the originals of these, try and pay a bit more and try and seek out the originals, even if they have to come from a broker that has to try and source them for you. If they look too good to be true, don't bother. You might cause yourself more issues. I'm glad it wasn't in the switching circuit or something, because that might have caused some more serious issue. It's a shame I can't get these genuine Tiouden inductors anymore, but we'll see how we go on with those. Again, they claim to be rated at 3 amps at the matching inductance, so these ones that actually came out of it are only rated 2.4 amps. So if they worked for 8 years and it was only a severe overcurrent that blew them up, then hopefully if we don't have that happen again, the other ones will be fine. But as I say, I hope that was helpful to someone. I'm rambling on now, so I'm going to shut up and go away and say thank you very much for watching.